Sledheads, welcome back. We are looking at the world's most expensive fuel system for a snowmobile, I am positively sure. This is going to be the plan for Bob in the new Skidoo trail tank. It's an aftermarket tank based off of Skidoo. What I have here is a Bean Machine micro sump. This is about 3 inches in diameter, and you essentially you drill an 1.5 inch hole in the bottom of the tank, and then you bolt this up to that, and it's just a sandwich fitting with a rubber O-ring around it. So that will allow all the fuel to slosh from the tank and back and forth, and then end up collecting down here. Then I've got an 8 AN to 8 ORB fitting, so that'll screw into that. And then there'll be 8 AN line from Fagola here all the way to this pump. This is a Walboro, genuine Walboro, 255 LPA. So I had to get an M1 by something adapter. I'll have to look that up, put it in the comments. But and then an 8 AN fitting for that, an 8 AN fitting for that, then a 90, then an 8 ORB that the 90 screws into, then this fitting, and then this will go up to the rail, which the rail I've already put on. Where's my rail? There it is. I got a 5/16 inch to 8 AN adapter fitting that's made for fuel rails. Pretty cool part. Okay, so what is this expensive thing here? This is the ID injectors, or what they call the F750 fuel filter. So this is a really nice piece. I figured with the since I'm running ID injectors, I just get the filter that they recommend. This is pretty cool. It measures the delta between an in and outlet, and this will tell you how plugged up or not your fuel filter is. So you can just look at it at a glance. You don't have to do anything. Then this is your canister. It's got this locking mechanism on it here to you open the lock, and then this will unspin. You can clean that. This was really expensive, and I justified it based on the idea that I might be able to rig this up so that I can swap it into my RX-7 way over there. That thing runs AN lines and ID injectors as well when I get done building that. So maybe in the summer I'll run it over there. In the winter I'll run it over here. I don't know. It's just a dumb way to justify expensive jewelry. Next part of Do Not Light My Ass on Fire is the fuel pump relay. So this was the root cause, or that we've determined is the root cause for my last setup here. I was using the stock wiring and running the in-tank Walboro tank fuel pump on it up to the stock fuse from 10 amps and 20 amps. Did that a decade ago. It's been great at 12 PSI, but as you put more load on them, say when you're in the 20s like I am, they get hot, and it got hot, and that's what started the foam on fire, which then wasn't actually the meth at all. So got me this is here it is. It's the Painless Wiring Kit 30 amp relay. And so it's got nice heavy duty gauge wiring. It's actually thinner than what I had before, but it's a lot better quality wiring. And then it also comes with a circuit breaker. So this is a circuit breaker that is basically, there's no switch or anything. There's a media in there. When it detects a lot of amp courage, say when you're current, when you're direct to ground, it'll melt, and then that'll separate it. And then as it cools back down, it'll make the connection again. So a pretty cool part that will keep me from burning up. Last piece of the puzzle is the heat shield. So I was going to bend up a piece of aluminum from scrap and then put like a reflector tape on there like this from DEI, that would probably suffice. But I got stumbling around looking for a piece of aluminum and things like that, and I actually found this from Heat Shield Products. It is called their Inferno heat shield. It's relatively thin. But there's a lot of air in there. It's hard to explain. It's almost a 1/4 inch thick, but it feels like almost like a pack of bubble wrap or something. And then in between there is, of course, a bunch of ceramic. This material is stainless steel, and it is said to withstand 2,000 degrees of continuous heat. So, they say trust but verify. let's set up a little test rig and let's just see how hot this material gets on the inside and on the back side, just so we are a little comfortable with the heat protection capabilities, since this will be separating a plastic fuel tank from a glowing hot turbine housing. All right, here's a little test rig I just made up. I've got the nozzle pointed about 2 inches from this side. I've got an extremely powerful heat gun here. We're going to take the temperature here and here and kind of calculate the difference or the delta after it runs for a few minutes. So just to start us off, we are sitting at 66 degrees, and let's turn it on, see what happens. All right, so we just turned it on. All right, that's been going for quite a bit now. I'm just gonna try to get in here and show the underneath surface temperature. Looks like 530 degrees or so on the bottom. About 130 on top. So still can't touch this. That's really hot, but that is what, 400 degrees difference. So 130 definitely won't melt any plastic on anything. So I would consider this a win. Pretty cool product. I'll also maintain an air gap between this and the tank. So, and I'm also going to coat the tank with some of the DEI hot shield on the inside of the tank that would kind of match this surface, or kind of be, you know, about a ½ inch or so from this surface. So try to reflect as much heat as we can and keep me from burning up.